Hello everyone, welcome back. Here's vanAmsen, and today we have a fascinating problem ahead of us, night probability in chessboard challenge. So this problem really resonates with the chess fanatics among us, and it's going to be a great blend of probability, dynamic programming, and dash of chess. So without any further ado, let's dive right into it. So what's the problem? We have a chess knight that makes key moves on n times n chessboard. What we need to calculate is the probability that the knight remains on the board after it's done moving. So now this problem can initially seem a bit complex, but we will break it down together. So we are going to solve this problem using JavaScript, which is a versatile language, great for this kind of algorithmic problem as well. So I'm trying to explain it. So knight probability function, which takes 4 parameters: the size of the board and the number of moves key, and the initial position of knight R and C, so row and column. So first, let's establish the possible moves a knight can make. So as we know, a knight has 8 potential moves on the chessboard, and we will store these moves as an array of pairs, each pair representing the row and column shift of each move. So let's implement it. So const moves will be 1, 2, 2, 1, minus 1, 2, 2 minus 1, minus 1, minus 2, minus 2, minus 1, 1 minus 1, minus 2, 1. And now onto the core of the programming. So dynamic programming, we will iterate initiate to the array dp and dp previously each of size n. So array length n, new array n fill 0, and let dp previously will be array from length n, new array fill with 0, new array, and fill 0. And now dp previously rc will be 1, and for let step 0, step less than key, step plus plus. So what we did. So now onto the core of the programming solution. So this will help us track the knight position probabilities for each move. And the knight starts at position RC, so row column. So we set it to 1 because it's one probability that it's on the board. So next we need to calculate the probabilities for each move step. So for each call and cell on the board, we calculate the probability that knight ends up there after each move. So considering all 8 possibility move, and this is done by checking if the moves keep the knight within the board, and if it does, we are adding the previous steps probability divided by 8, as there are 8 possibilities moves to the current probability. So for I 0, I less than n, increment, and second loop, let j0, jn, increment, and dpij will be 0, and for direction in moves, so direction row column, previous row will be I minus direction, and let previous column will be I j minus dc. Okay. So if previous row 0, previous less than n, previous, and so we are checking whether it's on the board or not in constraints, and dpij plus dp previous row, previous column divided by 8 float. So now closing all, and yeah, so we have calculated, and once we calculated the probability for a step, we swap our DP and DP previous arrays, and this way DP previous always hold the probability for the latest calculation step, while DP is ready to hold the probabilities for the next step. So DP previous will be DP previous DP. So it's a swap. And now we calculate total probability. So initially it will be 0. So yeah, and we iterate over DP previous array to calculate the total probability that the knight remains on the board. So this total probability is just sum of probabilities of all cells on our gaming board. So let's implement it. So let I0 in increment j 0 j less n increment total probability dp previous and return total probability. Okay, so here we have our implementation. So we can run it and see if it's working for given test cases. So yeah, it looks like it's working. So all good. So we have implemented our night adventure journey on the chessboard. So when we run our function with the input from the problem statement, it's calculated correctly. So those are probably easy test cases. So let's submit it for unseen test cases as well. And it's running, and yeah, we have successfully solved it, and we beat 62% with respect to runtime and 93 with respect to memory. So it's quite memory efficient, and this problem is a great example of how dynamic programming can simplify a seemingly complex problem. And I hope you enjoyed our journey today in the world of chess and probabilities. And if you have any question or need further clarification, don't hesitate to drop a comment down below. And thank you for joining me today, and I will see you in the next video. And remember, in the game of coding, always aim to be the knight and keep practicing. Happy coding. See you next time.